In today's lesson, we're going to be talking about the sine rule. Let's now consider any triangle. In other words, we do not need a 90-degree angle here. We'll call these non-right angled triangles. Here I have a diagram of a non-right angled triangles with angles capital A, capital B, capital C, and sides opposite of them, small a, small a, small a, small b, small c. The sine rule says side A over the sine of angle A is equal to side B over the sine of angle B, which is equal to side C divided by the angle, sine of angle C. When do you use this? If you have, just look at this here. We usually set a proportion up with just two fractions. If you have side A and side B and angle B, you can solve for angle A. If you have this angle and this side, you can solve for B. We need two angles and a non-included side, or two sides and a non-included angle, and we can use the sine rule. Let's use the law of sines to solve this triangle. I'm given triangle ABC where angle B is 83 degrees, and across from angle B I have side B 23.8 centimeters. I don't know side A, I don't know side C, I know angle A is 47 degrees. Well, I know that 83 plus 47 plus angle C must equal 180. So using that knowledge, I can find quickly that these must add up to 180, so that must be 50 degrees there. And now I'm ready to substitute. I know the rule of sines tells me A over sine A equals B over sine B. Well, B over sine B is 23.8 over 83 degrees. That's sine 83 degrees. And A over sine A, well, I don't know what A is, but I do know that we have sine of 47 degrees here. I can cross multiply. I get A sine 83 degrees is equal to 23.8 times sine of 47 degrees. I can divide both by sine of 83 degrees, divide both by sine of 83 degrees. These will cancel, and I'm left with A is equal to 17.5 what? Centimeters. In this same problem, I can use the sine rule again to find C. I already found that this here is 17.5 centimeters. Now I'm just left with sine C. I use my sine rule again. C over 50 degrees, sine 50, is equal to B over sine 83. I can cross multiply and I get C sine 83 degrees equals 23.8 times sine of 50 degrees. Divide both by sine of 83 degrees, sine of 83 degrees. Make sure your calculator is in degrees, and you get C is equal to 18.7 what? Centimeters. 3 sig figs, correct units. What happens when you're using the sine rule and you have to solve for an angle? Well, here is a triangle given that across from 40 degrees we've got 10. And across from sine angle C, we've got 7. And we want to find angle C, for example. Well, I can use the sine rule and say 10 over sine 40 is equal to 7 over sine C. If I cross multiply, I get 10 sine C equals 7 sine 40. So far, so good. Now I divide, this is times 10, so I divide both sides by 10 and I isolate sine C. Well, what do you do here if you want to solve for the angle? Sine C equals something. What you do is you take the arc sine of both sides, or you take the inverse sine. So I take the inverse sine there, and I also take the inverse sine here. So my answer is that C will equal sine with this inverse signal or notation times 7 sine 40 degrees all over 10, and when you plug that into your calculator, you get 26.7 degrees. We're talking about degrees. This is an angle.